going about the design process, we broke up every system into an individual component and designed a lot of iterations. We would brainstorm individually, and then we came together at the end to compile all our results for all of our systems and come up with the best final option for everything, and then we integrated it all together in a design. When we compiled our final design, we settled on a barrel that revolves, pulls back hammers, which then strike notes. It was a very simple design, and so all we really needed was one motor to turn on to drive the entire thing. We also have a dampener which gets pushed back by solenoids, and when it's released, it'll press into the chimes and muffle the noises so we can have one clean song without a lot of resonant frequencies going all around. We settled on having 12 chimes for our song, which was Cornfield Chase, which has 12 different notes if you rip out the bass clef.
We made sure to utilize on-shapes in context and parametric design functionality in our model because it allowed us to be more flexible with the way that we designed our parts and made sure that they meshed together better.
After we finished with the CAD, the next step was to begin physically working on the chime machine. We cut the chimes based on the lengths we had calculated, laser cut and 3D printed parts that would be needed for the machine, and wrote the simple code needed for the machine to function. Initially, we printed with PLA, but due to the lower resolution and structural integrity, we decided to use PLA for testing purposes and used resin printing for the final pins. We designed the chime machine in a way that we could each work on it simultaneously by designating subsystems for each individual to work on. Using this system, we constructed each side of the chime machine, the striking mechanism, and the chimes in 1 week. We then worked on the barrel together since it was a more complicated structure.
Our chime machine has a lot of features that might not be noticeable on first glance. For example, our barrel here is completely removable. You simply have to take off these little latches on each side that prevent it from coming up, and then you can just pull the barrel out. Being able to take the barrel out makes it much easier to encode the barrel and put these pins in, and it also makes it easier to work on the inside of the chime. Having the barrel and the chime separate also enables us to work on the two simultaneously. A fundamental portion of our design is our 3D printed pins pulling back on the strikers. This allows us a lot of flexibility in our design, but there's inherent risk involved because if the pin pulls back the striker too far, something is going to break. That's another reason that we used 3D printed resin for our pins, because it's a very brittle material that will snap easily. That means that if a pin is too long, instead of breaking a striker or the barrel, it'll break the pin. And we have hundreds of extra pins, and it's a very common point of failure.
While we were proud of our final result, there were a couple of ways we could improve on our design if we had more time, or the opportunity to construct a second version. Since we only had a semester to work on the project, some aspects were rushed. One of those was the barrel assembly. If we had more time, the barrel would have been more circular instead of malformed. This would ensure that no pin would have to be shaved in order for the song to work properly. We would also make an adjustable position for the dampener to sit on so modifications as necessary could be made. This would make the dampener more effective and it would interfere less with our chime. Also, if we had more time, we would spend a lot more time adding support where necessary.